Okay, today's lesson is about polygons. So the first thing we're going to learn about is the polygon interior angle sum. The segments that connect the non-consecutive vertices of a polygon are called diagonals. Drawing all the diagonals from one vertex of an n-gon separates the polygon into n-2 triangles. The sum of the measures of the interior angles of the polygon can be found by adding the measures of the interior angles of those n-2 triangles. So, the formula for the polygon interior angle sum is the sum of the interior angle measures of an n-sided convex polygon is n-2 times 180. This is a really important formula for us today. N represents the number of sides and if you take the number of sides of your polygon and you subtract 2 from it and then multiply by 180, that will give you the sum of the interior angles in that polygon, okay? So, I would recommend that you get a calculator for today's lesson because some of these answers are going to get quite large. So we'll go down here to our exercises to begin. It says find the sum of the measures of the interior angles of each convex polygon. Now the first one is a decagon. Do you know what a decagon is? Do you know how many sides a decagon has? Well, let's make sure that we know those words before we get started. The smallest polygon has 3 sides, and a 3-sided polygon, of course, is a triangle. And we've already learned about triangles a lot this year. A 4-sided polygon is called a quadrilateral. A 5-sided polygon is called a pentagon. Okay, so we got triangle, quadrilateral, pentagon. A 6-sided polygon is a hexagon. A 7-sided polygon is called a heptagon. And these start getting harder to draw the more sides you have. One way to draw one is to put the same number of sides that you're going to have in a circle. 1, 2, 3, 4, 5, 6, 7. And then connect the dots with straight lines. An 8-sided polygon is an octagon. That's the one that is the shape of the stop sign. So you see these a lot. And a 9-sided polygon is a nonagon. A 10-sided polygon is a decagon, which is the one that we just saw for problem 1. That's what we're going to need, a 10-sided one. An 11-sided polygon is an undecagon. A 12-sided polygon is a dodecagon. A 13-sided polygon is a 13gon. And it goes on like that from there. 14-sided is a 14gon. Okay, so you can just take the number of sides and put -gon, and that will be what's left beyond that. Okay, so we're going to go down here to this section and we're going to find the sum of the measures of the interior angles of each convex polygon. So for the decagon, it has 10 sides. So we're going to use the formula n-2 times 180. So the number of sides is 10 minus 2 times 180. So 10 minus 2 is equal to 8, and 8 times 180 is what we're going to need to do. And like I said, you might want to use a calculator because these numbers are going to get big today. So we'll go 8 times 180 and that gives us 1,440. So 1,440 degrees. So just like a triangle has 180 degrees, a decagon has 1,440 degrees. So that is quite a bit. So for the 16gon, we go 16 minus 2 times 180. And then that, of course, would be 14 times 180, which gives us 2,520 degrees. Okay, for a 30gon, we go 30 minus 2 times 180. So that's going to be 28 times 180, which is 5,040 degrees. And then for the octagon, that's 8 minus 2 times 180. So that's 6 times 180, which is 1,080 degrees. 12gon, we're going to do 12 minus 2 times 180, which is 10 times 180, which I don't even need a calculator to do because all I have to do is put another 0 on there, 1,800 degrees. And then this last one is 35 minus 2 times 180. So 33 times 180 gives us 5,940 degrees. Okay. Now, the next section says the measure of an interior angle of a regular polygon is given. Find the number of sides in the polygon. Now, these problems are going to take up quite a bit of room. So I recommend that you get a separate sheet of paper because we're not going to be able to fit it here to do these problems. So for number 7, we're trying to find out if each of the interior angles of a polygon measures 150, how many sides does it have? Okay, there's quite a few steps on these, but each of these are going to be just the same. So bear with me as we do the first one. They're all going to work out quite the same way. So the formula for the number of degrees in a polygon is n minus 2 times 180. But that's the total number of degrees. So if I wanted to know how many degrees was in just one of the angles, I'd have to take that and divide it by the number of angles. Now keep in mind, this said that it's a regular polygon. A regular polygon is one where all the sides have the same length and all the angles have the same measure. So if you just take the total and divide it by the number of angles, you get the degrees for each individual angle. So we're going to set this equal to whatever number they give us in the problem. In this case, for number 7, it's 150. And now we have an algebra problem where we need to solve for n, which means get n all by itself. Now you can't ever solve for a variable that's in the bottom of a fraction. So the first thing we need to do is multiply times n on both sides of the equation. So we have n minus 2 times 180 equals 150n. And then we want to distribute the 180, which means we multiply it times both of the numbers inside of the parentheses. So this is 180n minus 360 equals 150n. And now we want to get the like terms together. So I'm going to keep my negative 360 here and get my n's together on this side. So I'm going to subtract 180n on both sides of the equation. So I'll have negative 360 equals 150 minus 180n. So that's negative 30n. Then to get the n completely by itself, I'll divide both sides of the equation by negative 30. So n will equal negative 360 divided by negative 30, which is positive 12. So this means that there are 12 sides to the polygon that has each angle measure being 150 degrees. 12 sides to the regular polygon. Okay? Now they have 6 problems here. We're not going to do all 6. We're going to do number 7, number 9, and number 11 here. So next we'll do number 9, and you'll see it's going to be just worked out just the same way. Instead of having 150 though, we have 175. So for number 9, I'm going to say n minus 2 times 180 divided by n equals 175. So this is the same way I set up the first one, except I've taken out the 150 and changed it to a 175. Now we're going to solve for n. So I'm going to multiply both sides by n to start. Times n times n. These n's cancel out. So I have n minus 2 times 180 equals 175n. Now I'm going to distribute the 180. So I'm going to multiply it to each of these in the parentheses. 180n minus 360 equals 175n. Now I'm going to get the n's together. So minus 180n minus 180n, negative 360 equals negative 5n. And then the last step is to divide both sides by the negative 5, so my n will be completely by itself. And negative 360 divided by negative 5 is 72. That is a lot of sides for our polygon to have. 72-sided polygon, a 72-gon. All right. I recommend that you pause the video now and try number 11 on your own, and then come back and check to see if you got it right. So find the measure, the measure of an interior angle of a regular polygon is given. Find the number of sides in the polygon if each interior angle is 144. Okay, I'm hoping that you paused your video and that you got the answer. So now we'll check and see if you did it right. It's n minus 2 times 180 divided by n is equal to 144. So the first step is multiply times n on both sides. These n's cancel out. So I have n minus 2 times 180 equals 144n. Now I'm going to distribute the 180. So I've got 180n minus 360 equals 144n. And now I'm going to subtract 180n from both sides of the equation. Negative 360 equals negative 36n. And now I'm going to divide both sides by negative 36. So n is equal to 10. Did you get 10 sides? It's a 10-sided regular polygon, so that would be a regular decagon, just like we talked about earlier. Okay, let's look at number 13. Number 13 says find the value of x. Well, this is kind of like one of those problems where they ask you to find x when it was in a triangle. Remember, you had to add all the angles together and put it equal to 180. Well, this one is going to be done quite similarly, except for they don't equal 180 this time. This polygon has 1, 2, 3, 4, 5 sides. So it's 5 minus 2 times 180 to get the degree total. So 5 minus 2 is 3. And 3 times 180 is 540 degrees. So I'm going to write an equation here where I'm going to add 7x plus 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 equals 540 degrees. That is a lengthy equation. The good news is it's not going to stay that way. We're going to take 7x plus 4x plus 5x plus 6x plus 4x. So that's 10x plus 9x is 19x plus 7x is 26x when you combine all the x terms together. Combining like terms from algebra. Now let's combine the constant terms. 5 minus 5 is 0, plus 10 is 10, plus 10 more is 20. So plus 20 equals 540. Now we have to get x by itself. So we'll subtract 20 on both sides. 26x equals 520. Divide by 26 on both sides to get the x all alone. And then x is equal to 20, which is the answer to this problem. Okay, on to the back. We have here the polygon exterior angle sum theorem. The sum of the exterior, remember exterior means outside, angle measures of a convex polygon. One angle at each vertex is 360 degrees. So this one is quite a bit easier than the interior angle sum, because on the exterior angle sum, it doesn't even matter how many sides we have, they always add up to 360. So if you look at this picture, this angle plus 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 this angle will all equal 360 added together. So this next section says find the sum of the measures of the exterior angles of each convex polygon. A decagon, they add up to 360 exterior angles. It doesn't even matter how many sides the polygon has. 16gon, they add up to 360. 36gon, they add up to 360. So that's a pretty easy kind of problem. The answer is always 360. Just important to read the directions carefully so you know which kind of angle you're talking about. Now, the next section says find the measure of each exterior angle for each regular polygon. So this is a little different because the total is 360, but they want to know if they are all the same, because we're talking about a regular polygon, how much would each one be? So, for example, on number 4, if it's a 12gon, you're going to take 360 and divide it by 12. Because there's 12 exterior angles and they're all going to be the same. So 360 divided by 12 is equal to 30 degrees each. Okay? So on a hexagon, you're going to take 360. We're always going to start with 360 on these exteriors, but to find each one, divide it by the number of sides. A hexagon has 6 sides, and that will give you 60 degrees for each one. So a 20gon will be 360 divided by 20, which is 18 degrees for each one. Okay? Why don't you pause the video and try, let's see, well, number 8, 10, and 12 on your own, and then we'll check those and see how you did. Okay, so I was kind of mean to give you number 8 to start off with because it doesn't come out evenly like the others I did. 360 divided by a heptagon has 7 sides, gives you 51.4 degrees, approximately. That's a decimal approximation for the answer. We'll just round off to the 10th place. So, I hope I didn't worry you too much that I gave you one that had a decimal, but sometimes they don't come out evenly, and that's just the way it is. On number 10, we have a 24 gone. So 360 divided by 24 is equal to 15 degrees. And on number 12, an octagon has 8 sides. So 360 divided by 8 equals 45 degrees. All right, I hope that you learned a lot today about polygons, and good luck with your homework. Please let me know if you need any help at all, and have a wonderful day. Bye-bye.